intervals, which we already kind of introduced yesterday. This is just day 2 of it. So we're just continuing on with the concept of confidence intervals. Now, we're going to talk about the point estimate for a population. Now, there's this new symbol here that we call p hat, and that's because that little symbol there we just call a hat. Okay? So the proportion of successes in a sample. Proportions of successes in a sample. Think about a test. If you took a test that was worth 20 points, and you got a 17 out of 20, does that mean you got 17 correct out of 20? It means you were successful on 17 of the 20? That's kind of what we're talking about here. The p hat is x, the number of successes in the sample, over n, the number in the sample. Now remember, we talked about this yesterday, that the margin of error, capital E, is denoted by this formula. This is your z-score, okay? And then we're going to have our new symbol, p hat, and 1 minus p hat. So again, think about it. If I got a 17 out of 20 correct, that means I got 3 out of 20 incorrect. I got 3 wrong. So 17 right, 3 wrong. This is kind of like p hat, and this is 1 minus p hat. So, let's go from here. So the confidence interval, based on our margin of error and our levels of confidence, those numbers are carried over from yesterday, is going to be our p hat. Now remember, yesterday it was our mean. And then z-score, our margin of error. Z-score, p hat, 1 minus p hat, and n. Now, conditions. You gotta have conditions, make sure, check for normality, is n times p hat has to be greater than or equal to 10, and n times 1 minus p hat, which is very similar to what we just did yesterday. It's just now we're using p hat, but it's the same concept. Nothing really new there. Now, we want to identify n and x, find p hat, which is just x divided by n, remember. Okay. Verify that the sampling distribution can be approximated by the normal distribution. So check our conditions. Find the critical value z, whether it's 1.65, 1.96, or 2.58, given the level of confidence, 90, 95, 99%. And then find the margin of error and the confidence interval. Just put it all together. So let's do this real quickly. Not that bad. In a survey of 1,219 U.S. adults. That's going to be our N. 354 said their favorite sport was football. Okay? So in other words, 354 out of 1219. Okay? Think back to our quiz. 17 out of 20. 354 is the amount, not that they were right, but that's the number of successes. Those are the ones who said yes. Whatever. So 354 and n is 1219. Now, p hat is just literally 354 divided by 1219, which is 0.29. In other words, 29% of the people said football was their favorite sport to watch. Okay? And now think about it. If 29% said yes, what's the percent that said no? That's going to be our 1 minus p hat. So let's check our conditions. N times p hat. So 1219 times 0.29. Is that greater than 10? Well, let's see. 1219, it's going to be obviously, but times 0.29, 29% of 1219. is 353.1. So that's check. It is bigger than 10. Now we also have to check n times 1 minus p hat. So that's going to be 1219 times 1 minus 0.29. So think about it. If I got 29% on a quiz correct, that means I got 71% wrong. So 1219 times 0.71 is 865.49. Well, that's definitely bigger than 10 also. So our conditions have been met. Now, find the z-score for a 95% confidence level. Well, that's going to be 1.96. That's just off the chart. Okay? Now we're going to build our confidence interval. Of course, I just wrote all this for the confidence interval where the condition should be. So all of this, sorry, should have been written up here. My bad. So we're just going to do the confidence interval right here on the right side. So first we're going to find our big E, our margin of error. Okay? And that's going to be our z-score times the square root of p hat 1 minus p hat over 1219. And that works out to be 0.025. Now, our confidence interval is going to be p hat plus or minus e. So our p hat, remember, was 0.29 plus 0.025 and 0.29 minus 0.025. And that's going to give us 0.315 and 0.265. So my confidence interval is from 0.265, lost my 6 in there, to 0.315. And we can write it like that. We can also write it like this. And that's my confidence interval. Okay, let's do one more, and we should be good to go. Because again, this is just repetition of what we did yesterday, just with a new term. So, the 2016 survey, this is a distractor number. Of the 279, that's our number, 189 voted. We're also going to be looking at 99% confidence interval. And remember, the associated z-score with that is 2.58. So, x is 189, n is 279, p hat is x divided by n. That's 6.68 or 68% of the people. So 68% voted, which means 32% did not. That's going to be our 1 minus p hat. So, conditions. Now I'm going to try to write it in the correct space this time. N, which is 279. If my border wouldn't freak out. N, which is 279, times p hat, which is 0.68, is 189.72. Check, that's greater than 10. Then we have to do n, 279, times 1 minus p hat, which is at 30.32 or 32%, and that equals 89.18, which is also greater than 10. So check, both conditions have been met. The z-score, again, we said is 2.58. So now let's do our confidence interval. So first off, our error, margin of error, is going to be 2.58 times the square root of 0.68 p hat times 0.32, which is 1 minus p hat, over 279. That equals 0.072. My confidence interval, again, is p hat plus or minus that number e, 0.072. So it's going to be 0.68 plus 0.072 and 0.68 minus 0.072. This is going to be 0.752, and this is going to be 0.608, which means my confidence interval is 0.608 to 0.752. And that's it.